Hi class, in this video we're going to walk through correlation and regression in SPSS. And with correlation and regression we have a few different assumptions that we should check. And before we've talked about univariate normality, but we haven't checked bivariate normality, linearity before. So we're going to use a graph real quick to get a sense about that. And that graph is a scatter plot, which in SPSS is under graphs, scatter dot. We're just going to do a simple scatter. Because the end expectation is that volume is going to be y and extroversion is going to be x when we do the regression, we'll go ahead and set up the chart this way. Still, it really wouldn't matter on some level if we're getting a sense about linearity between x and y, which order we pick, but this would make the chart better fit the regression that we'll end up doing. We're going to go ahead and hit OK. And so from this, I can see that there is a relatively linear association. So as x goes up, or extroversion, we see that volume preference tends to also go up. There is an individual who would be considered a bivariate outlier. Additionally, when we look at this, it seems like the variability, so we've talked about homoscedasticity, variability on the lower end may be a little bit higher than the variability towards the upper end. So that would be something we would want to look into. For the purposes of an undergrad class, I'm just expecting you to look at this and generally think about those things from a visual perspective. For the correlation, if we go under Analyze, Correlate, we are doing bivariate correlations, meaning that we correlate two variables, bi meaning two, and we are going to correlate extroversion and volume. I've changed it to one tell because the expectation of the researcher is that as extroversion goes up, it will also be the case that volume preference tends to go up. So I'm setting it as one telled. If you wanted it to mirror other things, you could change it to two telled and then look at how that works. If you want to look at Excel and some of the t distribution formulas in Excel, you could do that as well. Under options, I'm not going to do anything there. I'm not going to change anything under style. We don't talk much about alternative types of statistics, but do know that Kendall-Tau, Spearman's rho, those are two different types of correlations that help to deal with data when it's more rank ordered. And again, we're not going to go into that in an undergraduate course, but just so you're generally familiar, if we violated assumptions, we wanted to treat the data as ordinal data, we could do that with either Kendall's tau or Spearman's rho. When we look at this, we find that our Pearson's correlation, R, is 0.912. If you look at the Excel, whenever you did it there, you can see that that is consistent with what we found. N is 40. Significance is 0.000. Of course, it can never truly be zero, so we would report that as less than 0.001. For regression, if you go under Analyze, Regression, we are working with a linear regression, but as you can see, there are a number of options here. As you go further into statistics, then you start to get into logistic regressions, multinomial regressions, those types of things. For the moment though, we're just going to keep things simple. We do need to now specify our dependent variable and our independent variable. So it's no longer just are they related, but does it seem that one predicts the other? Now again, is our data sufficient to say that? That is a question philosophically. If we recorded both of these at the same time, it's possible that really we don't meet all those assumptions. In the lecture video, we go through some of the assumptions that Cosby goes through of if we are going to make a predictive statement, if we're going to say that A causes B and have this directional causal relationship, we need to meet certain criteria. So keep in mind that that is always in the back of our mind. We should be checking those things. But as this video focuses on performing it in SPSS, we won't focus on that. So we're going to specify that extroversion is our independent variable, predictor variable, volume is our dependent variable or volume preference. For statistics, we're going to get the regression coefficient estimate. We can also get a confidence interval around that estimate. We need those confidence intervals to help remind us that, yeah, we have an estimate, we have a best guess, but we're going to be wrong a little bit almost all the time. We can then get model fit and descriptive predictors. We could also do collinearity diagnostics. This would only be necessary if we had multiple predictors, so that's something that we tend to focus on for later tests. So we're going to click continue. Under plots, it is important that there not be a relationship or a linear association between your predicted values and your residual values. By residuals, that's really the deviations between y and y prime or y hat, so the predicted value of y. So as y and y prime deviate from each other, right, that's our residual, and then the predicted value. If there's an association, that would suggest that we probably need to add in some x squared variable or something like that. We need to evaluate that. We're not going to go into that in depth, but it is something that I want to put on your radar to check. We can also save the unstandardized predicted values. This is y prime or y hat. So that is what is our best guess about volume preference based on their extroversion score. And under options, we're not going to do anything there. We're not going to do anything under style. I'm going to hit OK. When I scroll down, I see that R is the same as the correlation because I only have one predictor. So that's why that is consistent. If you start adding in multiple predictors, that R value will then change from just your correlation value. Our test of significance, we find that it is less than 0.001. So this uses an F test, but the outcome is consistent with our outcome from the t-test that you saw for the correlation. And in fact, by each individual variable, we do have a t-test for each individual variable. Now there's only one variable, so in this case, extroversion is predicting volume preference. So this t-test of 13.693, that t obtained, should be consistent with the t obtained that you saw when we did the correlation in Excel, because in the Excel video, we go through how do you take R and basically turn it into t obtained. And so this value is consistent with the value you'll see in Excel. Our ultimate outcome is that it is less than 0.001. We see B, again, that's the change in extroversion to volume. So as there's a 1 point change in extroversion, the change in volume preference is 1.087 decibels. And we can look and see, we have this one person that's really kind of out there. That's our bivariate outlier that we saw before. Otherwise, the relationship between this is relatively flat. Maybe there's a little bit of a curve here, but it's not anything that we're probably particularly concerned about. Additionally, when we look back in our data, we now have the predicted values. So this is the predicted volume. So I could then calculate deviations y minus y prime. And what that would be is take the volume and then subtract the predicted value. And then doesn't evidently like y prime. We'll call it y predict. Hit OK. Still doesn't like it. Must be the minus sign. We'll just write the whole thing out. All right. This then gives us our deviations. So how off are we about each person? Like I said before, if your extroversion is 10, right, my best guess at your volume preference is 61.2589. However, this person wants it a little bit quieter, right? And this individual wants it a little bit louder than our best guess based on their extroversion, so our estimate based on that. So from that, we see that you can then get your deviations. And then, of course, you could square those, look into that as well. But that lets you know where the numbers are coming from, what the numbers mean, and importantly, how to run a regression in SPSS.